All right, so good everyone, and welcome once again to Justified series. And today, our focus for today is what? Physics practical. So now, firstly, let me keep my phone first coming. All right, so now, firstly, my name is Justified, and you are welcome to Justified TUTOR'S Academy. Now, before I begin, I would like you to know this. If this is your first time coming across this channel, ensure to like this page, like the video, like, yes, then subscribe. See it, subscribe to this channel because it is very, very important if you want to keep on seeing my videos, as they are very, very helpful. Students have testified over the years. And ensure to comment anything that you feel you do not understand. I get me. Ensure to comment anything that you feel or any suggestion, and then I will what? I will take note of it. So, like I said in the beginning, our focus for today is what? Physics practical. First of all, I want to say congratulations to you guys. You will soon be out of school. I think next week you guys should be done, and then start signing out. Have you start signing out? But then ensure to put my signature on all your shirts. This is my signature here. Yeah. Put it on your shirts first and let me sign on your shirt. So let's leave all the gist and let's dive straight into business. So there are some things you need to know about physics practical if you want to have an A1 in physics, because of, yes, in case they did not tell you, physics practical carries more mark, or if you do your physics practical, your chance of having an A in physics is very, very high. That is why you must not neglect physics practical. So now, first of all, let's dive straight into the specimen that WAEC has given to you guys. Now, this is it here. It will be displayed on your screen. So, where's it again? So yes, the first question, they said that you should get 2 retort stands with clamps, thread, 2 identical spiral spring, a meter rule, masses, stopwatch, an optical pin, plasticine, pendulum, and 2 screws of uniform thread. Now, what this basically is talking about, I think this is basically a question under it could be either under pendulum, but at least the pendulum moves like this. Are you getting me? Or it can also be under some what's called it? I've forgotten the name of that thing again. But then that's not our focus for today. My focus for today is to show you some things, because of your practical will be carried out should you get in the examination hall, right? So that's my business. My business is for you to be able to carry out the practical well. So now let's dive straight into an example that you need to know ahead of your physics practical. Let's dive straight into it. Okay, so I have one here from last year. This one is under question. Okay, let me just look for a particular question from that fits this year's specimen. Let me see. Come in. I want to see a question that fits this year's specimen. Okay. Let me see. Does it fit it? No, it doesn't. It doesn't. Okay, but let's just start with this one. So I'm going to display on your screen a question from the year 2022. I getting me? The year 2022. So just go to the question as you can see on your screen. So you'll be asked to carry out this practical, blah 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 blah, down to look at Roman figure VII. Do you get? Look at this Roman figure. So now they will ask you repeat the procedure for 4 other values. That is, in this one now, in question 1, they said that you should get masses of 150 gram, 200 gram, 300 gram, and 350 gram. So they will ask you to repeat the procedure for all of these grams. But that's not my focus. Now, my focus now is where they ask to plot a graph. So they will now ask to plot a graph T. So you get plot a graph T on the vertical axis and M on the horizontal axis. So now the graph will not be drawn to scale, but then I want to show you something. So T is what? They said T, plot a graph T on the vertical axis, this is T here. And then what? M on the what? Horizontal axis, this is M here. Right? So you should plot the graph what? T with respect to what? That of M. So now let's say that what? The graph slopes like this. Let's say it slopes like this. Right? You have your first point here, you have your second point here, you have your third point here, fourth point here, fifth point here, and what? Let's say your sixth point is here. Are you getting me now? Let's put some other points here that are not fitting. Let's just say all of these ones. Now follow me, follow me. They will now say you should what? You should find the slope, determine the slope of the graph. Now, in physics or physics practical, to determine the slope of the graph, your slope must be what? 3/4 of the graph. That means 75% of the graph. So if you want to determine your slope, you can start from any point here. You see, from any point here like this, just pick it like this, down to what? To this point here. Like this now, you've already picked your slope. Are you getting me? But make sure that what? Your slope is not tiny. It must be what? More than what? 75% of the graph. Now that you're not taking your slope, how do you now get your what? Your slope value? How do you get the value for your slope? Now, your slope is what? It's called S, right? Now, S will be what? S will be change in what? Abi? We're dealing with what? We're dealing with. Okay. So, we're dealing with what? This is T square, I beg. This is T square, guys. This is T square. And this is what? M. So, now, for us to get our slope now, this is already our slope like this. So, this is it here. For us to get our slope now, the formula will go to be what? It will be change in what? In T square over what? Change in M. That's the formula for slope. If this was y square, it would be what? Change in what? That is change in the vertical axis over what? Change in the what? Horizontal axis. Right? So now you pick out the values for this side. This one now, you trace it here. Pick out the value. This one also, you trace it here. Pick out. So this will be your T2. So we'll be having it like this. T2 square minus what? T1 square over, that is, this one is your what? T2 over your T1, right? And then what? This will be your what? Your M1, and this will be your what? Your M2. So it will be M2 minus what? M1. The values you get, divide them, and what? That will be your what? Your slope. Simple as ABC. Are you with me? Please note that what? Your M2 must always what? Be bigger than what? Your M1. Are you getting me? So that is how you do it. I'm just showing you how you do it so that you can easily what? Know how you do it in examination, or just ensure to complete your table, because of there is a table that's what you must complete, and there is a trick for this table. But then there's one thing about WAEC is that your values must correspond in your what? In your center. So if I give you the trick now, it might not really work for you guys, except you guys decide to cooperate. And you might just be the only one watching this video. Your friends might not be the one might not watch this video at all. You get, except to share with them. But then I will not teach you guys that so that I don't confuse you guys. But then now let's move on. After you've now drawn your graph, you will get your what? Your slope. Then they will now ask you more questions. So let me keep this on the board. They will now ask you more questions. Now, this is where I want you guys to pay attention. So now, this graph that we did now is a graph for meter rule. You know, when it's a graph for equilibrium. You know, when you have what? A meter rule like this, and then you have what? A knife edge. Yeah, exactly. This graph, this practical is under what? Equilibrium. Are you getting me? Now, these are the kind of questions they can ask you after you plot the graph, which is what my main focus for today. Now, the first one they can ask is what? Is to determine the slope, what I've already done. They will now ask to what? To determine a particular value. They can say evaluate Q is equals to what? 0.68 over S. They can say evaluate Q is equal to what? 0.68 over S. What this means that what? You should just divide 0.68 by the slope. I get me. So the slope is 5. With 5, you divide what? 0.68 by 5. You get your answer. That's it. Simple as ABC. Now, then they will now say again, state 2 precautions taken to ensure accurate results. Now, this is where many science students always feel it. Now, I will give you 5 precautions that you should know under what? Equilibrium of forces. I getting me? Precaution that you must take when you are dealing with practicals under equilibrium of masses. And the first one is avoid error due to parallax in the reading my meter rule. Now look at question 1, that is the practical one. Because of there is like you are going to be making the of meter rule there. That is why I'm using this example. Are you getting me? So the precaution you avoid the precaution you take is number 1, avoid error due to let me write on the board. So I'll rub this off. So now we are under what? Precautions. Please follow me carefully. And if you have questions, please drop in the comment section. All right, let's go. So let me write it here. Where did that thing fall? Oh, okay, fair here. All right, let me put it here. So we have precautions under equilibrium of forces. So I have number 1, avoid error due to what? Due to parallax error. I get him. Avoid error due to parallax error in, let me just clean this one. Avoid error due to parallax in the what? In the reading of my meter rule. Or is it avoid error due to parallax in the reading of my meter rule? Only God knows if English is correct. All right, so now that is the first precaution that you must take. Are you getting me? Please just revise it, and please let me confirm if this sentence is correct, because I'm feeling like it's wrong. Then the second error you should avoid is the second precaution you should take under equilibrium of forces is this. Number 2, you ensured that support was rigid. That's the second one. Ensure that support was rigid. All right, so that is the second one. So now moving on again, under equilibrium of forces, they cannot test you under the B part, which says that you should give 2 examples of simple harmonic motion. So learn simple harmonic motions. Go and learn it, yes, please, because of it will be important for your question 1. They can test that you should give examples of simple harmonic motion, or define it, or explain it. So you get. They can also ask to explain the term center of gravity, but I don't think they'll ask you that because we are not using knife edge here. Yes, we are not using knife edge here. So that is that on question 1. But that's not that. Let's take one more question again. Coming, let's go to the year 2022. Before we conclude, let's go to another year. Let's see what over. Okay, in same thing he did in here 2022. Okay, and let's see 2024. Coming. Okay, so now, 2024. Okay, same thing in 2024. So it seems like WAEC like to test you on center of gravity for question 1. So you guys should just prepare for center of gravity. That is something that has to do with using knife edge, or that's to do with equilibrium of force. Are you getting me? So now let's go straight into the second practical. Now this one says 2 beakers labeled A and B, measuring cylinder 500 ml, tripod stand, source of heat, pendulum, bulb, stopwatch, water, stirrers, 2 thermometers, and a thread. Now this question is under what I call for me, in my own term, I'll call it will I say immersion of a liquid. Putting a solid inside the liquid. That's what I'll call it in my own term, sure. But then this, but then it is what? It's more than that. Let's take a question on it. I'm coming. Yes, now let's take a question on it now. So now, let me see. This is a good question on it. Do we have masses here? We don't have masses, Abby. So this is not a good question on it. Let's go to last year. Let's see last year. There's a question last year. All right. So now last year. Okay, same thing to last year. So now let's look at it. Look at the question. They say using the spring balance provided, determine the weight of what? An object of mass this. Record this weight as W1. You can see all those stuff. You just they do practical, they go. That is not my focus. My focus is from what? Roman figure 5. So now let me rub this off. Roman figure 5. So now the next practical we are taking now is the practical on what? On immersion of a liquid. Immersion in a liquid. Anyone? So now let's go, guys. They say you should determine the slope of the graph. So when you are dealing with what? With the second practical, your graph should look like this. Like this. Pay attention, you can see it. They said that what? You should determine the slope. Okay, they said you should repeat the procedure with the object of masses this. In which case, evaluate V is equals to what? W1 minus W3 on the vertical axis. That means on the vertical axis, V is equal to what? W1 minus W. That is weight 1 minus weight 3. And on the horizontal axis, your what? Your U is equal to what? W1 minus W2. So, first of all, you plot the graph. And your graph should go like this. Yes, your graph should go like this. So let's say we have our what? Asterisk here. Yes, let's go. Then we have some outside, some stubborn idiots outside. We have them here like this. Yes. Okay, also, yes, please note, this your straight line should touch at least 5 points. 1, 2, 3, 4, 5. Please note, yes, you cannot just draw any line. It must touch at least 5 points. Please know, 5 points is the minimum. 5 points. So when we now have what? This straight line, for us to now what? Get our slope. Like I said again, you take what? 75% of the graph. 75, so it can come from here down like this, right? Then this one will come like this, join them here. So this is our slope. So pick our slope from this point. So now slope S will be equals to what? Change in what? In V over change in U. So change in V over what? Change in U. That's the formula for slope. You know hard. What is your V? Trace it. This is your V. So this will be your what? Your V2. Then your V1 will be here. This will be your what? Your V1. Then this will be your what? Your U1. Sorry, this will be your what? Your U2. And here will be your what? Your U1. So here we'll be having V2 minus V1 over what? Over U2 minus U1. You get your answer. Are you getting me? So once you got your answer, you are not yet done. You look at it again in the question. They said now what? State two precautions taken to measure accurate results. Now, precaution under what? Immersion of a liquid. Please, guys, write. Number 1, I carefully avoided parallax error. While reading the scale of the spring balance. I carefully avoided parallax error while reading the scale of the spring balance to ensure what? Accurate measurement. That is 1. 2, I checked and accounted for what? Any zero on the spring balance before taking measurements. Now, I'm giving you all these precautions so that you can know what to write, because during my time, they did not teach us. So now we go, they use Google, they search them. Hey, because they cram. I'm giving you guys now ahead of your exam, because your exam is on Monday. So I'm giving you guys this thing now. So please take it very, very seriously. If I'm too fast, pause the video or put it at what? At 0.5 speed and watch. Are you getting me? So now, the third one, in case you forget the first two, the third one is what? I handled the liquid because of in the specimen, you were told to what? To make use of water. So the liquid is what? Is water. So number 3 will be what? I handle the liquid carefully to prevent what? Any splashing, which could what? Lead to what? Loss of what? Material or what? Inaccurate readings. And number 4, I ensured that the object did not touch the bottom or sides of the beaker to what? Avoid interference with what? The false readings. So that is that. Now, under what? See, under this practical 2, I can bet you they will ask you to what? Either state Archimedes principle or state what? The law of flotation. Or let me go and check the one I've written down for you guys. They can ask you what? To state Archimedes principle, state the law of flotation, or you should what? State two differences between what? Density and what? Relative density. Yes, they can ask you all, or they can even ask you what? To define and explain what? Surface what? Tension. Yes, they can ask you all these things. So guys, what I've said, go and learn them. Go and revise them. You get? So that is for what? 2025. Now let's go to what? 2024 question on what? On immersion. All right, so now follow me carefully. Follow me carefully. All right, so now this one says you are provided a retort stand. Does this one have retort stand? Okay, this one's tripod stand. Anyone, tripod stand, retort stand, and the same thing. Let's go on. So now, question 1 for the year 2024 has to do what with what? Immersion in the liquid again. Like I said, I don't care about the practical aspects. That one carry it in your what? In your various what? Venues, and then what? Carry it out well. I get me, because when you make a mistake, it will affect your answer. Please, that's why in practical you cannot even use expo at all, because your readings gas correlate with what? With your teacher's own or lecturer, how do you call it in your school. Now let's go towards to the practical aspects. They said tabulate your readings, plot a graph of U1 on the vertical axis and what? U2 on the horizontal axis. Now you see this one, very tricky. They said you should tabulate your readings, then plot a graph of what? Of U1 on the vertical. You can see this vertical, this is where vertical is. U1 on the vertical axis and what? And then U2 on the horizontal axis. They now said starting both axes from the region 0, 0. That means this part here will be what? 0, 0. You know, normally you can start your axis at what? At any point. Like you can start your axis with what you want to do. But this one, they are being specific here now, so you have to key into it. So let's go ahead and develop our graph. Now again, when you are dealing with immersion of the liquid graph, the thing they always go like this. Most times it always goes like this. It always goes like this. Are you getting me? This is how it goes. So your graph has to go in this way. And note, 5 things has to click for you to draw. 5 things has to click for you to draw. So all these ones that are here like this, concern you. Now this one where we say 5 click, now it concern you. Are you getting me? So again, you draw your slope, or you pick out the points for your slope. Remember, it must be 75% of your graph. So it goes like this. I can pick this point like this, here down to this point. Is it straight? Not straight. Exactly now. So it can be here down to this point. Oh, come on. You get? So it can be like this. All right. So now, here will be sorry. So now the formula for slope will be S is equals to change in in U1 over change in U2. So here will be our first point. I'll call it U1 2. That is U1 in bracket, the 2 of it, and I'll call here the U2. Sorry, I'll call it the U11. Sorry, the U11. Yes, U11, U11, U12. And this one will be will be our U22. This one will be what? Our U21. So it will be what? U12 minus what? It will be what? U12 minus what? U12 minus what? U11 over U22 minus what? U21. So please don't get confused though. All these they are you up and down. You do this confuse person. So that is it. After the graph, they will now ask you to what? They will now ask you to what? To after you've gotten your slope, they will now this question now says that what? You should find K. Find K. That is what, and K is what? Equal to what? 1 over S. So what the rest is that what? Find what? 1 over the slope. That will be your what? Your K. That's just bonus mark for you guys. Now, the next one again is what? They said here again, state 2 precautions. They will surely ask you this one. So again, state 2 precautions taken to what? To ensure accurate results. You go again to your what? To your stuff. Write down this one again. Let me just add this one to it. Number 1, precaution that you took that you must take when carrying out practicals on what? On immersion of the what? Immersion in the liquid is what? Number 1, I avoided error due to parallax when reading the spring balance. Now you already have it. I cleared the mass thoroughly before what? Immersing in liquid L. That one you already have it. So you get to add them to it. And then what? There in this question, they asked them to what? To state Archimedes principle. And they said that what? They should also state 2 differences between what? Density and what? Relative density. Now that is that on what? On that aspect. Now the next question here I have again is on center of gravity. Okay, let's skip that part. Now let's dive to what? So we've already taken 2 on question 1, 2 on what? Practical 2, and now let's go straight into practical 3, which is the last practical. During my time, I was asked to answer 2 questions. I can't remember, but I know I was asked to answer 2 questions out of 3. I don't know how yours would be like, but then if you're asked to answer 2, for me, I always suggest you answer question 1 and question 2 because they are very, very simple. But for those interested in what? In question 3, here we go. So now, question 3 is always on what? On electricity. So now, question 3. Now, I'm going to start question 3 with what? With the precautions. Yes. I'm going to start question 3 with the precautions. Everybody write. I carefully avoided parallax error while reading the scale of the spring balance to ensure accurate readings. Well, that's 1. Number 2, I checked and accounted for any 0 error on the spring balance. Oh, sorry, this is for immersion. I haven't wrote down plenty here. Sorry, this is for immersion. I just checked now. I wrote down plenty already, but I think I've given you guys that already. So that's not any of my focus for now. So now for electrical practical now, sorry for that error. You can see that you avoided error this way. Anyway, so back to it for the electrical practical. So you can say that what I ensured all electrical connections were securely tightened. I ensured all electrical connections were securely tightened to prevent loose contact, which could what? Lead to fluctuating or inaccurate readings. You can see that. You can also say I avoided parallax error by positioning my eyes directly in line with the scale when reading the what? The ammeter or voltmeter for precise measurement. You can also say I checked and corrected for any 0 error on the ammeter and voltmeter before taking readings to improve what? Accuracy. You can say that. And number 4, you can also say I removed the key from the circuit when not taking measurements to avoid what? Unnecessary heating and what? Potential damage to what? To components. And you can also say for number 5, I took multiple readings at each data point and averaged the values to what? Minimize random errors and what? Ensure more reliable results. You can also say again that what? I ensured the apparatus calibrated and what? Regularly. I ensured the apparatus was properly calibrated and regularly checked for consistency throughout the experiment. So you can also say that. So that is what all the precautions you need to know under what? Under question 3, because of question 3 is almost the easiest because of every year they use they use what's called it electricity. Yes, question 3. So now let's start with this one. So question 3 now, you'll be asked to carry out a practical again. Repeat the procedure for R1, R2, and 3, 4, 5. She gets. Then they will ask to tabulate your readings. They will now say you should plot a graph. They have to plot the graph now. Now this is our focus again. Plot the graph. So this is the graph here again. Plot a graph of what? Of arrow on the vertical axis. Please, this is vertical. Arrow is here. And what? I minus 1. I minus 1 on the what? Horizontal axis. Right? They will now say you should what? You should draw your graph. Okay? So now, to draw your graph again, this one for number 3, it always goes what? Like this. She gets. So now, please again, it must touch 5 points. It can start from here 1, it can touch here 2, yeah, 3, 4, 5. But please, it must touch at least what? 5 points. She gets. Don't make a mistake. It must touch 5 points. It's very, very important in your examination. 5 points. All right. So now, they will now ask you to draw your slope. Pick your points first. Remember, 3 over what? Over 4 of the graph, which is what? Which is usually what? 75% of the graph. All right. So please, it must touch the graph. Oh, don't mind me. Oh. Let me even clean itself. 3 over 4 of the graph, not outside the graph. Inside the graph, I beg. Inside the graph. 3 over 4 of the graph. 3 over 4 of the graph. Like this. You can see it. So you pick your point. Pick your point. This one, pick your point. This is what? R2. This is going to be what? R1. This will be what? I minus 1, 2. Then here will be be what? I minus 1, 1. So your S will be what? Change in R over what? Change in I minus 1. Are you getting me? So that is it. So now when you've gotten your slope, this one now says find the intercept. Now, when you've gotten your slope, how do you now what? How do you find your what? Your intercept? All right. So now they said you should find your what? Your intercept. They said determine the slope of the graph and find the intercept on the vertical axis. That is, the intercept is where the graph cuts the vertical axis. So look at it. Where did it cut vertical axis? It cut it here. So this is what? This is your intercept. I get it. This is where it cut the vertical axis. If it was the horizontal, let's say it cut it around here. This would be your horizontal. This would be your intercept if it cut it here. So that is basically it. So now let's move on. They said that you should state 2 precautions. You can do that yourself. Then you now said again, question that comes out under this electricity stuff. You can ask you to state 2 advantages of a lead acid accumulator over a Leclerc cell. So that means go and study your cells and everything. Or they can give you a question on on resistor, which is what I'll be ending with today. Let's solve one question on resistor. So let's take a question on resistor and call it a day. So the question goes like this. It said that a parallel combination of 3 ohms and 4 ohms, it will be displayed on your screen. Let me even copy it down safe. So a parallel combination of 3 ohms and 4 ohms resistor is connected in series with a resistor of 4 ohms and a battery of negligible resistance, internal resistance. Calculate the effective resistance in the circuit. So they ask us to find the effective resistance, given that our 3 ohms resistor and our 4 ohms resistor are connected in parallel. Are you getting me? So you get. So given that this is connected in parallel, these 2 are connected in parallel in series with a 4 ohms resistor. So now what do we do first of all? What do we do is to first of all we find the effective resistance of these 2. Now when you are dealing with parallel combination or parallel let me see what English they use there safe. When you are dealing with parallel connection, let me see. Yes, when you are dealing with parallel combination, now what you do is what is use the formula 1 over what REF is equal to what 1 over 3 plus what 1 over 4. So this is how you do it, right? So this will give you what? What's the LCM here is 12. 3 in 12 will give us what? Will give us 4. 4 times 1 is what? Is 4. 4 in 12 give us what? Give us 3. 3 times 1 is what? Is 3. That will give us what? 7 over what? Over 12. So this is what? This is the effective resistance. But then for us to connect it in series to what? The other forms resistor, we have to turn it up and this will come down. So it becomes what? REF is equal to what? 12 over 7. Now, for us to now have what? Our final one connected in series with what? With the forms resistor, it becomes what? R effective is equal to what? 12 over 7 plus 4. 7 times 4 gives us what? 28 plus 12. 28 plus 12 gives us what? 0, 1. This is already 3, 4. That's going to give us what? 40 over 7. So this is what our answer. But then you must leave your answer in what? In decimal points. So 40 divided by 7. Let me just calculate for you guys. I should have done myself. But let me just calculate. 40 divided by 7. It gives us what? 5.71 ohms. So 5.71 ohms is our what? Final answer. And that is how you do it. So ladies and gentlemen, we have come to the end of what? Of today's class. You can see physics practical is even easier than what your chemistry practical. Than you have to be you go the cram. It's not just straightforward. Just carry out the practical well, and then what? You are good to go. So guys, I'm wishing you guys success. I will see you in my next video. That should be for either biology or economics. Yeah, but I'll see you in my next video. Ensure to what? To read, revise, and what practice well. All right, guys. I love you all. Don't forget to like this video, subscribe, and share with your friends. Let them learn how to do all this graph, and let them learn that what that line must touch at least 5 points. It is key. And also let them learn how to take out their slope from that line. Are you getting me? Please, all those things are key. That's what WAEC look out what to mark. Are you getting me? So that is it basically, guys. So I love you guys so much. I remain justified, and I'll see you guys in my next video. Bye for now.